Polar graphs. In this video, we want to learn how to graph polar equations. When we have polar coordinate, how we can graph polar equations. As you can see in these pictures, there are different forms of polar equations with different graphs. But what is important that when we want to graph a polar equation, we need to have R and data. So to find R, we usually replace numbers for data, find the R, and then plot the points on the polar coordinate and then graph the shape. We can graph equations that are circles, cardioid, or limacon, lemniscate, rose curves. But in this video, we only learn about 3 of these graphs. We learn about graphing circles, limacons, and rose curves. Let's talk about the graph of circles. Anytime we have an equation, we have a polar equation in forms of r equal a times sine or r equal a times cosine. A is the number. For example, we have equations of r equal 2 sine theta or 3 cosine theta or 4 cosine theta. So when we have equation in this form, the graph is usually a circle. If the equation includes sine, we have a circle on the y-axis. When the equation includes cosine, we always have a circle on the x-axis. And as you see that the diameter of the circle is always the same as number a. For example, if I have 2 sine theta, a is 2, that means the diameter of the circle must be 2. If you have 4 cosine theta, that means the diameter of the circle must be 4. Let's look at one example. We want to graph these equations using a table of values. To have a more accurate graph, it's better to create a table of values, replace numbers for data, and find R. And for data, since data is an angle, we always replace angles. And you can see a polar coordinate on this over here. We want to use that for graphing this polar equation. But first of all, let's look at the equation. The equation is r equal 4 cosine theta, which means the a is 4. When a is 4 and I have a cosine theta, I know that the graph of this equation is a circle. Since we have a cosine, the circle is on the x-axis, and the diameter of the circle is 4. So generally, I know that I have to graph a circle on the x-axis with the diameter of 4, but to have a better picture of my graph, I will create a table of value. That means we replace numbers for data, replace angles for data, and it's easier to only replace angles from 0 to pi, like 0, and I prefer to just go by multiples of pi over 6, which means just pi over 6, pi over 3, only these points. If you want, you can replace other points as well, but it takes just more time. We can just have these points and graph the equation. If I replace the data by 0, I know that the cosine of data, which is the cosine of 0, is 1, which means the r, which is 4 times cosine data. So if cosine data is 1, 4 times 1 is 4. So if data is 0, r is 4. Data is 0 means on this line, r is 4. 1, 2, 3, 4. That's my point. So now I will replace data by pi over 6. Pi over 6, the cosine of pi over 6 based on the table is root 3 over 2. And r is 4 times root 3 over 2, because cosine data is root 3 over 2. And if I simplify, it gives me 2 root 3, but I have no idea where is 2 root 3. So it's better to convert it into decimal using the calculator. And we know that is about 3.46 or 3.5. So if data is pi over 6, R is 3.5. 1, 2, 3.5. That's my next point. If I replace data by pi over 3, I know that the cosine of pi over 3 is 1/2, and R, which is 4 times cosine, is 4 times 1/2, which is 4 over 2 is 2. So for pi over 3, R is 2, 1, 2. So we have a point on the second circle. If I replace x by data by pi over 2, we get used to x and y because of other equations. Now I'm just keep repeating x. If I replace data by pi over 2, the cosine of pi over 2 is 0. And I know 4 times 0 is just 0. So for pi over 2, I have a point on the 0. If I replace 2 pi over 3, I know that the cosine of 2 pi over 3 is negative 1/2. And R, which is 4 times negative 1/2, is negative 2. And we learned in the previous video that if R is negative, we have to find a point in the other side of the angle. So for 2 pi over 3, if R was positive 2, I had a point over here. But since it's negative 2, I will have it on the other side, which is 1 and 2. Yeah, it's over here. That's the point. If I replace the data by 5 pi over 6, I know that the cosine of 5 pi over 6 is negative root 3 over 2, and 4 times negative root 3 over 2, which is a negative 2 root 3, and in decimal is negative 3.46, or negative 3.5. For 5 pi over 6, which is this line, negative means so instead of having the points over here, I will have it on the negative direction, which is over here. Okay. And the last point, which is pi, I know the cosine of pi is negative 1, and I know 4 times negative 1 is just negative 4. So for pi, 1, 2, 3, 4, but negative 4, it's go back to the first point. Now I have all the points. And I know that I have to have a circle based on the equation. So we try to graph a circle by these points. That's it. And you can see that we have a circle, which is on the x-axis or the polar axis, and the diameter of the circle is 4. Now let's look at another equation. The equation is r equal to sine data. This time the equation, it has sine. The function in this equation is sine data. That means I should have a circle on the y-axis. And I know that the radius of the circle must be 2. But I still keep replacing numbers for data, find the sine of that, and then find the r. Using the same point, if I replace data by 0, I know that the sine of 0 is 0, and r, which is 2 times 0, is also 0. So 0 and 0. If I replace x by data by pi over 6, the sine of pi over 6 is 1/2. And I know that r, which is 2 times the sine data, is 2 times 1/2, and it's 1. So for pi over 6, we have 1. For pi over 3, I know that the sine of pi over 3 is root 3 over 2, and 2 times root 3 over 2 is root 3, which is 1/2, 1.7. So for pi over 3, we have 1.7. If I replace pi over 2, I know that the sine of pi over 2 is 1, and 2 times 1 is just 2. For pi over 2, we have 2. For 2 pi over 3, I know that the sine of 2 pi over 3 is root 3 over 2, and 2 times root 3 over 2 is root 3, which is 1.7. So 1.7. If I replace 5 pi over 6, I will get 1/2 for sine, and I will get 2 times 1/2, which is 1. So for 5 pi over 6, we are in 1. And the last point, which is pi, I know that the sine of pi is 0, and 2 times 0 again is 0. That means going back to the first point. Now, if you connect these points, you will see that we have a circle on the along the y-axis, and the diameter is 2. That's exactly the same as what we expect. Another form of equations are called Lemma-sums. Lemma-sums are the equations that are in this form: a plus or minus b times sine or b times cosine. When we have these forms of equation, depends on the number, the values for a and b, we have different shapes. If the ratio of a over b, that means if I divide a by b and I get a number which is less than 1, I usually have a Lemma-sums with an inner loop. And you can see the picture here. And if the equation has cosine, that loop is on the along the x-axis. If it includes sine data, that should be along the y-axis. If the ratio is exactly equal 1, you can see a heart shape. There is no inner loop, which is called Cartesian. If the ratio is a number between 1 and 2, we have a dimpled Lemma-sums, and there is no inner loop. And the picture is over here. You can see a picture of that dimpled Lemma-sum. And if the ratio is a number that's greater than or equal to 2, it's not exactly a circle, but there is also no dimple or no inner loop. Let's look at examples. We want to graph this equation: 1 minus 1 cosine theta. And this equation tells me that it's the equation of Lemma-sums. And an equation of Lemma-sums which a is 1 and b is also 1. And if I find the ratio of a over b, and if I divide 1 by 1, I get 1. And I know every time the ratio is equal to 1, we should have a heart shape. So for this equation, I also expect to have a heart shape. And since the equation has cosine, that heart shape must be along the x-axis. But how do we graph it? Create a table value. Replace angles for data, find the cosine, and then find the r. You don't necessarily need to write the second column for cosine. You can just replace the numbers into the equation and find the r. And just have a table with data and r. That's enough. If I replace data by 0, I know that the cosine of 0 is 1, and I know 1 minus 1 times 1, which is 1 minus 1 is 0. For 0, I have a 0. If I replace the x by data by pi over 6, I know that the cosine of pi over 6 is root 3 over 2, and 1 minus 1 times root 3 over 2. I cannot add or subtract because of the radical, but I can find the decimal value, which is 0.134. If I replace data by pi over 3, I know the cosine of pi over 3 is 1/2. And if I replace it for cosine data, 1 minus 1/2 is just 1/2, which means it's 0.5. So for pi over 6, I have 0.13, which is somewhere over here. For pi over 3, I have 0.5. Okay. If I replace pi over 2, I know the cosine of pi over 2 is 0, and 1 minus 0 is just 1. So it's exactly over here. If I replace 2 pi over 3, I know that the cosine of 2 pi over 3 is negative 1/2, and if I replace it, I will have 1 minus negative 1/2, which is 1 plus 1/2, and is 3 over 2, and in decimal is 1.5. So for 2 pi over 3, I will have 1.5. If I replace 5 pi over 6, I know that the cosine of 5 pi over 6 is negative root 3 over 2, and 1 minus negative root 3 over 2, which is 1 plus root 3 over 2. And the answer is 1.8, believe is 8, 1.8 or 1.7 something. 5 pi over 6 is 1.8. And for pi, cosine of pi is negative 1. 1 minus negative 1, which is 1 plus 1, is 2. So for pi, we have 2. Okay. You can see the picture. If you connect these points, you will get this shape. You expected to have a heart shape, but right now you have just half of the heart shape. For the other half, you can replace more points if you want, or you can use the properties of the symmetry. We know that this equation is symmetry about x-axis, because in the polar coordinate, the x-axis is called a polar axis. And if you want to make sure if an equation is symmetric about the polar axis, you just need to replace the data by negative data. If the equation doesn't change, that means it's symmetric. And in this equation, if I replace data by negative data, since we learned that the cosine of negative angle is exactly the same as the cosine of positive angles, and the cosine of negative data is exactly the same as cosine of data, you can see that the equation didn't change. When the equation doesn't change, that means it is symmetric. Okay, when it's symmetric about the polar axis, that means for all the points that are above the x-axis, we can have similar points under the x-axis, and for those that are under the x-axis, we can have same points above. So for every point that I have above the x-axis now, I can have another point under the x-axis. For this one, I can have here. For this one, I can have this point. And this one, and this one. And we can see that now we have a heart shape. Because of the cosine, I expected to have a heart shape along the x-axis, and you can see that. Next equation. R is equal to 1 plus 2 sine theta. This time, the equation includes sine. That means I expect my shape be along the y-axis. But what type of shape do we have? It depends on A and B, on the ratio of A and B. A is 1, B is 2. And if I find the ratio of A over B, it's 1/2. And I know that if the ratio is 1/2, which is less than 1, I should have an inner loop limescence, but along the y-axis. So it is less than 1, so we should have the inner loop. Okay. Now let's create a table value, replace numbers for data, and find the R. If data is 0, the sign of 0 is 0, and 1 plus 2 times 0 is just 1. 0 and 1. That's my first one. If I replace pi over 6, The sine of pi over 6 is 1/2, and 1 plus 2 times 1/2, which is 1 plus 1 is 2. So for pi over 6, we have 2. If I replace pi over 3, I know that the sine of pi over 3 is root 3 over 2, and 1 plus 2 times the root 3 over 2, which is 1 plus root 3, and root 3 is 1.7. If I add it by 1, it gives me 2.7. So for pi over 3, we have 2.7. For pi over 2, I know that the sine of pi over 2 is 1, and 1 plus 2 times 1, which is 1 plus 2, is 3. For pi over 2, we have this point. For 2 pi over 3, you can replace more points, or you can also use the properties of the symmetry. So for the first 2 quadrant, I prefer to just replace points. If I replace 2 pi over 3 for data, the sine of 2 pi over 3 is root 3 over 2. 1 plus 2 root 3 over 2, which is 1 plus root 3, is 2.7 again. So for 2 pi over 3, we have 2.7. If I replace 5 pi over 6, I know that the sine of 5 pi over 6 is 1/2, and 1 plus 2 times 1/2, which is 1 plus 1 is 2. For 5 pi over 6, we have 2. And if I replace pi, sine of pi is 0, and 1 plus 2 times 0 is just 1. But if you connect these points, you see that you expect it to have an inner loop. But you can see that the inner loop is missing. Because of that, I'm going to add more points. For example, I'm just adding 3 pi over 2 as well. Because I know that the sine of 3 pi over 2 is -1. And 1 plus 2 times -1, which is 1 minus 2, is -1. For 3 pi over 2, when r is -1, that means instead of here, we should have a point here. And now we see that the inner loop is creating. Now, if I connect the points, we have a limacon along the y-axis because we have sine, and there is an inner loop as well. If you want more points to give you an idea about the inner loop, you can replace pi over 4, 3 pi over 4, or any other data from the polar coordinates. All of these angles, you are free to replace them for the data. And another forms of the equations are called Rose curves, are the equation that they have sine or cosine of n data. N is any number. It can be even number, it can be odd number, it can be 2 data, 3 data, 4 data, 5 data. And if we have equations in this form, usually when we graph them, we have Rose curves. So the equation, the graph gives us some pedals. And depends on the number, which is even or odd. If n is even, we always have 2 times of that pedals. For example, for sine of 2 data, n is 2. N is even. That means when you graph it, you should have 4 pedals, 2 times of that. But if n is odd, you have the same number of pedals. You can see here, n is 5. When n is odd, that means you have the same number of pedals. That means if you graph this one, it gives you exactly 5 pedals. And you can see it on the picture. N is 3, is odd. So I expect to have only 3 pedals. N is 4. even, that means I expect to have 8 pedals. And if the equation has cosine, you can see that always some pedals crossing the x-axis. If the equation has sine, always some pedals are along the y-axis. Let's look at examples. We want to graph this equation, r equals 3 cosine 2 theta. This equation is a rose curve, and I know n is 2. When n is 2, that means it's even. That means we should have 4 pedals. Okay, how we can graph it? We can replace numbers. Again, create a table value because we're using a table of values. So let's replace numbers for data and find the r. If data is 0, let's start with 0. The 2 data is 2 times 0, which is 0. The cosine of 0 is 1, and 3 times 1 is just 3. For 0, we get 3. If r is pi over 6, if data is pi over 6, remember that you're finding 2 data. If data is pi over 6, that means 2 data is pi or 2 times pi over 6, which is pi over 3. That means you want to find the cosine of pi over 3. And the cosine of pi over 3 is 1/2. And 3 times 1/2 is 3.5, which is 1.5. For pi over 6, we are in pi over 5. If I replace pi over 3, I know that the cosine of 2 data means the cosine of 2 pi over 3. And the cosine of 2 pi over 3 is, let's look at the table. For 2 pi over 3, the cosine is negative 1/2. And 3 times negative 1/2, which is negative 3.5, which is negative 1.5. So for pi over 3, I have to go on the other side because I have a negative r. So negative 1.5. If I replace pi over 2, the cosine of 2 pi over 2, because 2 data means 2 pi over 2, which is the cosine of pi, and it's negative 1. And 3 times negative 1 is negative 3. So for pi over 2, we have negative 3, which is over here. And let's replace, so far I can see that I have 2 pedals. You can see the pedal. And I should have 2 other pedals. That means I can replace pi. If I replace pi, the cosine of 2 pi is 1, and 3 times 1 is 3. So for pi, we are at this point. That means we have another pedal here. And we should have another pedal on this side as well. If you replace 3 pi over 2, it gives you exactly this point. And now you have, I know that we can replace more points to get more accurate graph, but it's okay. For this class, we are fine with just having a few points and have a picture of the equation. R equal 4 sine of 3 data. Again, that's rose curve because of sine 3 data. And n is 3. When n is 3 is odd, that means we have 3 pedals. Okay, let's create the table value. Data and r. If I replace 0, let me just find the sine of 3 data first. and r. The sine of 3 times 0, which is sine of 0, is 0, and r is 4 times 0, which is 0 again. If I replace pi over 6, I want to find the sine of 3 pi over 6. 3 pi over 6 means pi over 2, and the sine of pi over 2 is just 1, and 4 times 1 is just 4. So pi over 6, 1, 2, 3, 4. It's over here. For pi over 3, I want to find the sine of 3 pi over 3, which is sine of pi. And sine of pi is 0, and 4 times 0 again is 0. Go back to this one. Let's replace pi over 4 here. If I replace pi over 4, I'm going to find the sine of 3 pi over 4. And based on the table value, the sine of 3 pi over 4 is root 2 over 2. And 4 times root 2 over 2, which is 2 root 2. And if you find it by the calculator, 2 root 2 is 2 times 1.4, which is 2.8. So for pi over 4, we have 2.8. 1, 2, and 2.8. Okay? You can see we can have more points. Let's replace pi over 2. Sine of 3 pi over 2, which is negative 1. And 4 times negative 1 is negative 4. For pi over 2, we have negative 4. 1, 2, 3, 4. Now you can see I'm creating the pedals. 1, 2, just the third one has left. I'm going to keep replacing numbers for data. If I replace 2 pi over 3, that means I want to find the sine of 3, 2 pi over 3, which is sine of 2 pi. It's a 0, so it's a 0. If I replace 5 pi over 6, that means I want to find the sine of 3 data, which is 3 5 pi over 6. If I simplify 3 and 6, gives me 5 pi over 2. What's the sine of 5 pi over 2? I know that the sine of pi over 2 is 3 pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. 5 pi over 2 is exactly in the same point as pi over 2, which means the sine of 5 pi over 2 is the same as the sine of pi over 2, which is 1. 4 times 1 is just 4. For 5 pi over 6, we have 4. Okay, now I have my third pedal. I expected to have third pedals, and you can see that I have them all.